Hi, my name is Brian Caffo, and this is the lecture on Shiny in the Data Products class. This class is co-taught with my collaborators Jeff Leake and Roger Peng. We're all in the Department of Biostatistics at the Johns Hopkins Bloomberg School of Public Health. Okay, so what is Shiny? Shiny is a platform for creating interactive R programs in a web page. Let's give an example. So your boss comes in and you've created a prediction algorithm, and they want you to put it up in a format so that lots of users can access it, and they don't all have to come to you to get their predictions. They want to be able to point and click them, but you want to be able to do it quickly. You don't want to involve legitimate web development and these other things. So anyway, using Shiny, the time to create simple yet powerful web-based interactive data products in R is minimized. It lacks the flexibility of full-featured and complex solutions where you create a full web interface on from scratch and call servers that you've designed. But on the other hand, the development cost is so small using a tool like Shiny. And anyway, Shiny is made by the fine folks at RStudio, which is a product that we really support and highlight in this series. So some mild prerequisites, and since I am not a web developer, maybe I'm not the best person to be teaching this class, but I don't even play a web developer on TV. But let me give you my understanding of the prerequisites. So some mild prerequisites. So Shiny doesn't really require it, but with all web programming, you need to know a little bit of HTML. At the bare minimum, you have to know some HTML, and some a little bit of CSS and JavaScript is certainly going to be helpful to be effective with Shiny. Just a little bit, not much. So if you haven't seen these things before, HTML gives the web page structure and sectioning as well as markup instruction. CSS is the style, and then JavaScript is basically most web pages that have interactivity. It's JavaScript that's giving you the interactivity. So, certainly you wouldn't come to us as PhD statisticians to learn about web development, and there's so many tutorials online that you can get them from so many places. I would hesitate to even recommend one. The Shiny, the style it uses is the so-called Bootstrap style, which has no relation to the statistics Bootstrap, which, as far as I'm concerned, looks nice. And more importantly, I think whenever you develop a little Shiny app, to me it always seems to render nicely on mobile platforms kind of automatically, which is the benefit of using this sort of highly polished style guide platform with Bootstrap. So look it up. I believe it's made by the folks at Twitter. So what else is out there? There's another product that I feel like we have to mention, but it requires if you really want a great solution and you know a lot of web programming, kind of client server type programming, then you can do your own solution in a variety of ways, and with some CGI script type thing. But that's way too in depth for this class, which is focused on people who know R and know some statistics and want to deploy what they're developing quickly. There's also this great project called OpenCPU by a person named Jerome Ooms, it's a great product. It's I think probably more flexible than Shiny, but again it requires much more kind of knowledge of web programming to really be able to implement. Not much, but more. I think, but it's a more flexible platform for doing these sorts of things. He even hosts an open CPU server, but then he also shows you how you can create your own. So let's give the context. You created a novel prediction algorithm to predict risk for diabetes, and you're hoping patients and caregivers will be able to enter their data and, if needed, take preventative measures. and you want to create a website so that users can input the relevant predictors and obtain their prediction. You're a prediction algorithm, okay? So you're not going to win a Nobel Prize for this one. Is you take their glucose level and divide it by 200. And since this is an obviously serious topic, here's a link for a pretty simple but real prediction score for diabetes. But again, I would emphasize about prediction scores, it depends on who the proposed clientele is. The clientele that have been referred to a clinic are going to be different and entering in different values than if you're asking everyone who has the slightest potential idea that they might have diabetes without having seen a caregiver. These two groups would be very different. So anyway, I just want to point out that there's a lot of intricacy in creating prediction algorithms. So let's go through it. Make sure you have a good, nice late release of R installed. If you're on Windows, you got to have R tools installed. You can grab Shiny from CRAN with installed up packages. You got to say library Shiny, which I won't repeat from now on. There's mostly what I'm going to do in this is go through the tutorial at RStudio, but hopefully in a little bit more didactic and simple way. So basically, we're just going to go through their tutorial. I'm a huge fan of RStudio's manipulate function, huge fan of it. So often if you want to do something in Shiny, but you just want to do it for yourself, or you're going to do it for someone else who uses RStudio, manipulate is this awesome, simple little function. It handles so many little tiny nice special cases, and it's I really like it. R charts will be covered in a different lecture for interactive graphics that use some modern JavaScript libraries. So how do you create a Shiny project? You need two parts. One is you need a file named ui.r, and they have to be in the same directory. One, you need a file named ui.r, and one you need a file named server.r. And we'll show in a minute how you can change. You don't actually need a ui.r function, but for right now you do. So you need those two files. If you have those two files, so here's a minimal ui.r function. You're going to say library Shiny just to make sure that Shiny's loaded. You have the Shiny UI function, and you say page with sidebar, which gives you the page format, and we'll see in a minute. I'm going to give a header that says data science for the win, and a sidebar panel that where I label it with sidebar text so we know where it's at, and then in the main panel I'm going to put main panel.txt. Some important things to note: that the H3 here is just the third level HTML heading. So I'm just saying I want this. Basically what Shiny is going to do is it's going to translate this into the third level HTML heading on the fly for you. So it's going to be that size. So, and it's hopefully the notation is clear. H1 will give you H1 heading, H2 will give you H2 heading, and so on. P will give you the P will give you P will give you that guy, and so on. And then my server.r, it's going to do nothing, but I just need this function Shiny server. It takes input and output and returns, in this case, null. Okay. To run it, you change into the directories with these files and type run app, or you can put the path as an argument, and it should open a browser window with the app running. So here's kind of what it would look like. It's chopping off part of the main panel just to make it fit on the page for me here when I cropped it as an image. But here's, it renders the text, hello Shiny, here's sidebar, here's main panel. Okay, here's the example for our functions with markup. So you can our functions will insert the HTML markup. So the header panel is going to say illustrating markup, so remember that. And then you got to remember that the commas are what kill you with Shiny. So remember that you got to have commas between things, and then say for example no comma right there. So H1, I'm going to say H1 is that the sidebar panel, and then there's got to be a comma there. H1 text, comma there, H2 text, comma there, H3 text, comma there, and so on. And so all of these things will render in the sidebar panel. The main panel, I've got three things: some main panel text, some code formatted as the code, and P, some ordinary text right there. Okay, so this is just a simple UI function that shows the rendering. So here's the illustrating markup statement. It rendered as H1, and then in the sidebar it rendered the sidebar panel labeled right there. There's my H1 text, my H2 text, my H3 text, my H4 text, my main panel text. Here's what it renders code like by default, and here's some ordinary text. Okay, and again, this is all squashed, right? The main, when you do this, you'll see that it looks different. There's a lot more white space over in that direction, but just to show you. Okay. Let's see, I wanted to show an example of input. So remember, the header is going to say illustrating inputs. The sidebar panel, I'm going to put in a numeric input, and you'll see what I mean by that. It's a little box where you can enter in a numeric input. Here's the label, so it is exactly the HTML label. And then here's the printed label, numeric input labeled ID1. Here's the default value, the minimum and the maximum, and a step value, and you'll see what the step value does. And then here's a checkbox. It's labeled ID2. I put it in, I label it as called checkbox, and here's the different values that it can give. Here it is date input, and then the main panel I'm just going to leave blank in this example. And here's an example. Here's the example. When you run it, you'll see. So when you push this button, it's going to increase or decrease the numeric input as per the step size. And I must have had different code than I have right here, because this says 0, but it starts at a default value of 5, or maybe when I grabbed this screen grab, I was playing with it. And then here's the checkbox, right? Check it, and date. When you click that, it'll actually bring down a calendar that you can take, grab the date from, and then here I wanted to show how you can grab the outputs. So here and display the outputs. So here in as H3 text, I'm going to say illustrating output. H4, I'm going to say you entered, and then I'm going to say output ID1, output ID2, and output date. Okay, and so that's how I'm going to render the output. But notice I got to grab these OID1, OID2, and ODate variables. Where do those come from? Well, those come from your server function. And my server function just says, it takes in my input, which is my input ID1. So this is where it grabs the HTML labels, right? ID1, ID2, and date. And then here, render print is just saying the output is going to be formatted as printed text. So output OID1 is going to be printed, just reprinting the input ID, and so on. Okay? And here we go. So here, here you see, it's easier for me to just do the screen grabs than to illustrate it in real time. So here you can see it starts at default value 0. I could press up and down on that 0 to change the outputs over here. Whatever you check over here. So I check the two values, and you can see they come out over here as you entered 1 and 2. The 0 is you entered 0, and then I click the date, which I think was actually the date I was doing this, and it says you entered that date. Okay? Okay, and here it is actually live. So in my RStudio, I typed run app, in the directory that contained this code. This code is in the GitHub repository, and you can see as I enter in numeric input, as I increase it to 5, it's changed to 5 over there. I check value 1, value 2, value 3, value 2, value 1. I can grab a new date, okay, and so on. Okay, so that's just what that's showing you how you can get from your inputs to the server, then back to the outputs. Okay, so now that we have our skills, let's build our predict function. Okay, so I'm going to go through all the little bits of this code, and then I'll pan out and run it real quick. Okay, so I'm going to do a page with sidebar because that's what I always do. You know, in Shiny UI, Shiny User Interface, I'm going to tell the people that this is a diabetes prediction algorithm. In my sidebar panel, it's going to take as numeric input, it's going to take something ID labeled glucose, and then I'm going to tell them what to put it in. And of course, I'm going to give them the units because I would be a monster if I didn't give them the units, right? That's really bad form. And then min, max, step size 5, put a default level as 90. Oh, this is cool. You can put a submit button in with submit, and you can see on the Shiny tutorial if you want it to not even implement the default values and to wait until the person enters in for the first time before for Shiny to wait till the first submit to actually run. But right now I think it'll go the first time, and then when you hit submit, it'll update it, but it won't update it in between. So there's a little bit of complexity with doing that. But anyway, you can add a submit button. I think it's called a go button if you want to actually predicate action even in the first instance with depressing the go button, which is a bit much for this class. I think we just want, you know, a submit button for right now. Just, you know, is probably good enough. You'll see the submit button when I show you the results. Here it's going to give you the results of prediction. Here's what you entered. It's giving you the input value, and which resulted in a prediction of, and it gives you the prediction value. So the input value is the output name that my server.r function labeled, and so this is going to print it out, and my prediction is the label name that my server.r function labeled prediction, whereas glucose is what my UI sidebar panel numeric input labeled as glucose. Okay, so let's go to the next thing, which is my server. So you can put your function up here at the beginning, or you can do an include statement or a source statement in case it's a long thing. So here's my function, and here it's function input output. Here's my input, my output value. Since I want to print out the input value, I'm grabbing the I'm labeling it input value, and I'm grabbing the input glucose value, and I'm telling it that what I want to do with this output is just print it. And then my prediction, I want to print it, and I'm running my function diabetes risk of for the input value of glucose. Okay, so hopefully this should be pretty simple to follow. So here's the result. You get to click on glucose, whatever you want. You hit the submit, and it says you entered, which resulted in a prediction of blank. So let's actually run it. So here it is in a tab for Chrome for me. Notice it runs the first one. If you want this submit button to not run the first one, then you have to program in, I think, what they call a go button, which it's not too hard, but let's I want to just focus on the core, getting kind of core functionality out. So let's say I wanted to predict at 1:15. Now it won't go until I submit. So you can see it. You put it in. So you want a submit button if the calculations take kind of long. If they go really fast, then why bother? Just have it update it real time. I do think it's generally good form to re-show the person the value that they entered. But there you go. That's what it gets for you. Okay, so let me go through showing an image, how to embed an image. And then let's put a slider on it. So we're going to create a histogram and put a slider on it so that the user has to guess the means. what I'm going to do is I'm going to create in my sidebar panel a slider input. Mu is going to be my label. I'm going to say guess the mean. You're going to start at a value of 70. It's going to slide from 62 to 74, and the step size is going to be 0.05. And then new hist in my main panel is not defined in this file. It's defined in my server.r file, where I define it as the histogram that I create based on the calculations that get done. Okay, so new hist is my label for my output created from my server.r function. Here's my server.r function. It's telling them the data set that I need to grab, any library calls. So here render plot is like render print, only it's going to render a plot. Here's my histogram, and then here's the just some generic R code. It grabs the input value, it adds lines at that input value, and then I give the person their mean squared error, and I tell them what their mu value and their mean squared error is. This all gets rendered in a variable called new hist in my output. So the new hist will be the HTML label that the UI function is calling, and it looks something like that. So there you go, and let's see it in action. Okay, here it is in a tab for Chrome. Here's my slider. I'm going to change it and see it changes my red line, and here's my mu value and my mean squared error, right? And so that's a nice little function that you can do, and it shows how it's rendering the image. So okay, so what's happening, right, is my UI.R is telling Shiny to create an HTML page with the slider. The slider creates a thing with a label. That label receives the numeric input value. That input value is passed to server.r. Server.r gives the instructions back to render the markup, giving it the plot and the output values, right, that go back with the instructions from UI.r to giving it on how to mark it up. Okay? Very neat, right? So you can get actually a lot tighter control over style. So all the style elements are handled through UI.r. But I think the first time I did this, now I just use UI.r, but the first time I did this, I was frustrated and I wanted a lot more control over the style. So you can actually have a generic HTML file rather than a UI.r function, which means then you get everything you can with HTML. So this link in the notes goes to the HTML needed. What you have to do is just, instead of get rid of your UI.r function and create a directory called www, and in that directory have a file called index.html. And then when you go to this link, it'll show you that basically how you have to just have the inputs labeled in a specific way, and then Shiny will recognize them. And so you just have to have specific JavaScript libraries installed and appropriately name IDs and classes. And this is sort of beyond the scope of this class, but I think for many of the students in the class, things like HTML are and JavaScript are very easy for them. And I think if you're familiar with JavaScript and HTML, and if you've learned this amount of Shiny just from this lecture, then going to have any looking HTML page that you want with Shiny embedded in it should be a relatively minor step. And so you can get it to look however you want then. But just go to this link and follow the conventions that they suggest. Okay, so this is just bare bones intro to Shiny. Some other things you can do: you can upload or download files from Shiny. You can have tabbed main panels. This is all within the standard UI.r function for tabbed main panels. You can have editable data tables. That's neat. You can have dynamic user interfaces. So based on values that you input, it can then show you new controls. You can user-defined inputs and outputs, which is sort of like programming more Shiny functionality. And then you can put a submit button so that Shiny only executes code after the user hits submit, even for the first time. That's covered in the tutorial on Shiny 2 as well. And so how do you distribute a Shiny app? So everything when you run Run App on your computer, you're running a little web server, and your browser is going through localhost to that web server and just connecting within your computer. But maybe you want to deploy it on the web. So I'm going to give a little lecture on how to deploy Shiny as a web service. But that's a little bit beyond what most people are going to need to do. The quickest way is just to either put it on Gist or GitHub or Dropbox or whatever, and send someone the app, and then they can call Run App and they can run it just like you would in development. That's pretty easy, but it requires and if you really want to be fancy, you can create an R package and create a wrapper that calls Run App. But all these solutions, of course, only work if the user that you want to reach knows R. If they don't know R, then this isn't an option. You can run a Shiny server, which of course requires setting up a Shiny server, which the instructions are here. If you know a little bit of Linux server administration, a little bit, not a lot. Certainly, I'm no expert, and I managed to do it. Then that goes a long way. You don't need to know a ton. They've made it pretty easy. So probably one of the easy solutions for that is you could run it on a virtual machine where they already have Shiny servers running well. So if you run it on Amazon AWS or something like that, then you might make yourself might make your life a little bit easier if you can find an instance where people have already done it. And of course, you have to have all the ports and everything opened in the right way and all that sort of thing. So anyway, setting up a Shiny server is beyond the scope of this class, but I'll have a lecture where I go through setting one up as a kind of extra material, but it won't be on the quizzes or anything like that. The same lecture, I'll show you how to set up an RStudio server so you can run RStudio from a web browser. There's groups. I think RStudio is one of them that's creating Shiny hosting services. So they give you the Shiny server, and you just create the app on their platform, and then they host it. Probably it'll be either a free or a freemium. I mean, most of these things will probably be like freemium services where you get a certain amount free, and then you have to pay for more. I think. I don't know. Obviously, I'm not them. By the way, if you're like me, one of the first things you do when you found Shiny is you tried to extend it kind of ludicrously, and R has the system call where you can call call the for example the Unix terminal. Don't do that, right? So don't put system calls in your code. So it's the first thing everyone who knows what system calls are, and the first thing that they do, because then they can do something really fun with it. But it introduces a lot of security concerns, and it's not really in the intention. Shiny is really for deploying statistics apps, not for running generic server-side scripts with R as the intermediary. Of course, why would it? There's already things to do that. At any rate, that's I would make that point. But of course, if you have your server locked down and you don't care if it crashes, then knock yourself out. But in general, put an ounce of thought about security before you deploy a Shiny app with sort of access to the operating system.